All right, today we're going to be solving radical equations. To finish up our unit here, there are some rules when you're solving radical equations, so we'll start with that. The first rule comes if there's one radical in the equation. In that case, it tells us to isolate the radical. That means we want to put the radical on one side of the equation by itself. Everything else moves to the other side of the equation. The second rule is if there's two radicals. In this case, you want to separate before raising both sides to a power. So you want to put one radical on the left-hand side of the equation and the other one on the right-hand side of the equation. So one on each side. And then the third one tells you to check your answers by substituting them into the original equations. That's always a good practice, is to check your work. But in this case, you need to check for extraneous solutions. So make sure you go back and check. We'll start with this easy example here. The square root of x plus 13 equals 5. In order to get rid of a square root, we want to do the inverse operation. And in this case, it's already isolated. There's nothing else on this side of the equal sign. So we can go ahead and square both sides, which is the opposite of the square root. That allows us to cancel out this radical with this 2 and free my x plus 13. It is equal to 25 now. That's what 5 squared is. I then subtract the 13 to get it to the other side because I'm solving like normal, and we get x is equal to 12. And that's what you would want to check your work with. But before we do that, I want to remind you from last class when we rewrote radicals as rational exponents. So in last class, we learned that the square root of x plus 13 is the same thing as x plus 13 to the 1/2 power. So the square root and the 1/2 power are both the same thing. In this case, to get rid of the 1/2, it would still be squaring it because that's the inverse operation. And whatever we do to one side, of course, we do to the other. So this 2 cancels out because one's in the numerator, one's in the denominator, and that's going to cancel it out and free that x plus 13 to be equal to 25. So whether you have it as a rational exponent or you have it as a radical, you should be able to solve that way. All right, now to check our work. You can do that by plugging it in and doing it algebraically, or you can use it on the calculator. I'll show you both of those. So we do the square root of 12 plus 13 is equal to 5, and we're checking to make sure this is a true statement. And so this would be the square root of 25 is 5, which is a true statement, and so that is our answer. 12 would be our answer right there for x. All right, to check this on the calculator here, we would do the square root of 12 plus 13. It is 5, which is what it said it was equal to here. So that works. All right, we're going to look at some more examples now. And we're going to end up changing this to a 4. So if you've got the notes page in front of you, make sure you change this second one to a 4. All right. For this one here, again, we've got the radical by itself, so we're ready to go. We square both sides. And so the square root and the square cancel, giving me 4 plus 7x is equal to 81. We subtract the 4 to get it to the other side, and we get 7x is equal to 77. I divide by 7, and x is equal to 11. Remember, don't stop there. Make sure you plug it in, and it does work. And so we take the square root of 4 plus 7 times 11, and that is 9, which is what it said it was equal to. So that works. That's my answer. All right, we're going to look at another one here that has the rational exponent. As a reminder from last class, the numerator, so 2, is the exponent of x plus 5, and the 3 is the radical. So this would be the cube root of x plus 5 squared. You should be able to write those back and forth. If you forgot, make sure you go back and look at that video. All right, to remove that 2/3 and free up this x plus 5, we want to raise it to a power that's going to make that cancel. And so if I raise it to 3/2 power, because the 3 is in the numerator and the denominator, it cancels, and the 2 is in the numerator and denominator, so that cancels that part, freeing my x plus 5. Now, of course, whatever I do to one side, I want to do to the other, so I would raise my 4 to the 3/2 power as well. Now, your calculator will do 4 to the 3/2 power, but I want to make sure that we revisit that part on how to do that without a calculator. So we said last time, on the inside part, you get 4 to the 1/2 power. So you keep this denominator part. And then you raise it to the 3rd power because that's the power to a power exponent. If we multiply these, we get the 3/2. So we haven't changed the value, we've just changed the way it looks. Now 4 to the 1/2 power, well, that's the square root of 4. We know what that is. And so we get 2 to the 3rd power, and 2 to the 3rd power is 8. So we have simplified that right side now. And then we subtract the 5, and we get x is equal to 3. And again, we would love to check our work. Now, a couple things to show you here on the calculator. You can put 4 to the 3/2 power. So if you're using a calculator, you can raise it to a power and then put in your 3/2. And it tells you 8, which is what we got algebraically. So that does work with the calculator. And now when we put this into the equation, we put in our 3, so we get 3 plus 5, and I want to put it in exactly the way it looks on my paper, raised to the 2/3 power. And that gives us 4. So that's to check our work there. I plugged in my 3 right here and got 3 plus 5 to the 2/3 power, and it was equal to 4, which is exactly what my calculator said here. So I've checked it on the calculator. This does work. Checked our work. And we did it algebraically to verify it there too. All right, we'll get on to some that are a little bit harder. So here we go. My radical is isolated. Again, that's the first step. Make sure it's by itself on one side of the equal sign, and then we can square both sides. And so our square root and our square cancel, freeing that, and I get x squared is equal to 6x plus 16. Now it's a quadratic. So I have to go back and think about, how do I solve quadratics? Well, we can solve them by factoring, we can solve them by quadratic formula, or we can solve them by completing the square, or we can solve them on the calculator by finding the zeros. Most of the ones we're going to give you here are going to be easy to factor, so that would be the easiest way to do it. In all 3 cases, we would want to get it set equal to 0. So I'm going to subtract the 6x and subtract the 16 to get it to the other side. Remember, with the quadratics, you want to get it set equal to 0 in order to solve. And so now we can factor, do the quadratic formula, or find the zeros. Again, most of the time they're going to be easy to factor. That's x times x, and then we're looking for what multiplies to be negative 16 and adds to be negative 6, which is negative 8 and positive 2. And then what makes that 0 would be an 8 and a negative 2. I don't want to box both of those answers. We've got to check them. You can check that with a calculator, or you can check it algebraically. So I do the square root of 6 times 8 plus 16. And there it is, 8, which is what we plugged in, so that works. And then the square root of 6 times negative 2 plus 16, and that gives us a positive 2, which is not what we plugged in, and negative 2 would be what's here. So that does not work. This one would be considered an extraneous solution. We would not want to mark that as a true solution. It is a solution to the quadratic, but it is not a solution to the radical. So that's how it gets introduced there. Because we're solving this quadratic, we ended up with the 2 solutions for the quadratic. It is just not the solution for the radical. So that's an extraneous. 8 would be our only true solution. And I want to show you that algebraically what that looks like if I put it here to check my work. Negative 2 is equal to 6 times negative 2 plus 16. As soon as I get to this point, I don't even need to go any further, because I know that everything that comes out of the radical comes out as a positive, and this is negative, so there's no way that that's going to be a true solution, so I knew it was gone at that point. All right, our next one, here's the cube root of 6x plus 10 equals negative 8. With the square root, there's no index written there, so it's a 2. When there's nothing written there, we know it's a 2. This one has a 3. So with the 2, we squared because it canceled that out. So with a 3 there, we would cube because that's what's going to make that one cancel. If this was a 4, we would raise it to the 4th power. If it was a 5, we'd raise it to the 5th power. So that cancels, and we get 6x plus 10 is equal to negative 8 cubed, which is negative 512. Now we're solving like normal. We subtract the 10, and we get 6x is equal to negative 522. And then our last step is to divide by that 6. And so we get x is equal to negative 85.33. Again, you can check your work. In this case, you can have negatives under a cube root, so it's not as important to check as the other ones, but of course you want to check it to make sure that you're always getting it correctly. To put the cube root in there, I'll go ahead and show you that. You go to math, and then you go down to that number 4 there. That's the cube root. And so we get 6 times, and I can go ahead and get that from there, plus 10. There it is at negative 7.94. So we got a little problem here. All right, sorry about that. I see what I did incorrectly here. Negative 522 divided by 6 is 87. Negative 87. I don't know what I plugged in earlier there. And if we check that one works. Sorry about that. So negative 522 divided by 6 is negative 87. All right, going on to 5 and 6 here. For number 5, and this one's a harder one because it's got an x minus 2 on the other side. And so we really need to think through this one. To get rid of the 1/2, again, we would square that because that's what's going to get those to cancel and free up my x squared minus 12. But then I'm going to have to go ahead and square this portion as well. You want to square the entire side of it. Now, x squared minus 12 is freed, but this side, you want to remember what x minus 2 squared means. That's x minus 2 times x minus 2. So you need to either FOIL it or use the box. And so when we FOIL it, we get x squared minus 4x plus 4. So that's what's going to go on this side here. Now, since it's a quadratic, we want to get it set equal to 0. Since this is positive, I'm going to subtract that x squared to get it to the other side. And so that cancels and that cancels. So the x squareds are actually gone and leaves us a linear situation. We want to get the x by itself, so we're going to subtract this 4 to get it to the other side. And that gives us a negative 16 is equal to negative 4x. We're going to divide by negative 4. And so x is equal to positive 4. We plug that in. And we get 4 squared minus 12. And I forgot to put the parentheses in there. Raised to the 1/2 power. There's my left-hand side, and my right-hand side would be 4 minus 2. And both of those are equal to each other, so I know I've done it correctly. That works. All right, we've got another one to try here. Again, we're going to square the entire side. The square root and the square cancel out, freeing my x squared plus 1. This side, we're going to have to FOIL x minus 1 times x minus 1. That gives us x squared minus 2x plus 1. So that's what's going to go on my left-hand side here. Now we're ready to solve this. We subtract the x squared to get it to the other side. And again, this one canceled out. Just kind of nice. It leaves us this linear equation. We subtract the 1 to get it to the other side, and we get negative 2x is equal to 0. And it's actually funny because at this point, a lot of students will say no solution, but that's not the case because we are dividing by negative 2, and 0 divided by negative 2 is 0. So it could work right there. 0 could be a possible answer. However, this one really is a non-solution Because when we plug in the 0 in our original equation here, we get 0 minus 1 on the left-hand side. And then on the right-hand side, we get 0 squared plus 1. And so that is negative 1 equals the square root of 1, which this is not true. You do not get a negative out of the square root, so that does not work. So this would be a no solution. All right, we've got a couple more to try here. We're going to try one with radicals on both sides now. Again, our first goal would be to isolate them on both sides, which they are now. So there is one radical on each side of that equation. And so I square both sides to get rid of the square root, and it actually gets rid of the square root on both sides. That's the reason why you want to have one on each side, is so that it cancels out on both sides. Freeze out my 5x minus 3 on one side and my x plus 13 on the other side. I'm now solving like normal, so I subtract this x to get it to the other side, and we get 4x minus 3 is equal to 13. I add 3 to get it to the other side, and we get 4x is equal to 16. We divide by 4, x is equal to 4. I check my work, and this one works. So there we go. All right, number 8. Again, we have a radical on both sides, so we're ready to square, and we do have to square the entire side. We can't just square the radicals, or we're changing the value of the equation. What that means here is that 2 must be squared as well, because it is not inside of this radical. So when the square root and the square cancel, you still have to get this to be squared as well. So 2 times 2 gives us 4 times the x plus 7 that's released from the radical, and then x plus 25 on the other side. We distribute, and then we solve like normal. So we're going to subtract that x to get it to the other side. We're going to subtract that 28. And then our last step is to divide by 3. This is another one that students mess up when they get to this point, and they're like, oh, it's not a solution because it's negative. But that's not the case. You can have a negative as a solution, because when we put the negative 1 here, it gives us a 6 under the radical. And when we put the negative 1 here, it's going to give us a 24 under the radical. So it doesn't make either one of those imaginary. It does work. So we'll do this one algebraically just to show you it works. We get 2. We said that's the square root of 6 is equal to the square root of 24. Now we go back to, remember, to simplify this radical. The biggest perfect square that goes into that is 4. And so the square root of 4 is 2, and 4 times 6 gives us 24. And so there they are the same. So negative 1 is a solution. All right, over to number 9. Our radical is not isolated. It is not by itself on one side of the equal sign. So our first step is to get rid of this 2, bring it to the other side. So we subtract that 2, and we get the square root of 2x minus 6 is equal to 3. You've got to get it by itself, isolate it. If you tried to square that whole side, you would have to FOIL that, just so you know. That's why we isolate it. Now we square both sides. That frees up my 2x minus 6, and 3 squared is 9. We add the 6 to get it to the other side, and we get 2x is equal to 15. We divide by 2, and x is equal to 15 halves. That one does work when we plug that back in. So we're ready to go to the next one. All right, we've got x is equal to negative 1/2. In order to get this to cancel, we want to raise that to the power of negative 2, because that's what's going to cancel those out. And whatever I do to one side, I'm going to do to the other. So I'm going to raise that to the negative 2 power. These cancel, and we get x is equal to, now as a reminder, to get rid of a negative exponent, we do the reciprocal, we flip it. So that would be 9 squared. That's what gets rid of that negative. And 9 squared is 81. So even though that one looked really hard, it's not that hard. You just want to think through the process. Make sure that you get something that cancels this, and so that would be 2, because -1/2 times the -2 gives us the 1. All right, we are going to look at a couple word problems. Luckily, the word problems with radicals are pretty easy. It's using that same type of solution. It says the speed s that a car is traveling in miles per hour and the distance d in feet that it will skid when the brakes are applied are related by the formula s equals the square root of 30 times f times d. F is the coefficient of friction, which depends on the type and conditions of the road. The length of Sylvia's skid marks was measured at 110 feet. If F equals 0.4 for a wet concrete road, how fast was Sylvia's car going when she applied the brakes? So we really need to think through what is being talked about here and how it's going. So S is the speed, and they told us, S is the speed, and that's what the speed she's traveling at. Square root of 30, F is the friction, and D is the distance of the skid marks. So when we plug this in, we are looking for her speed. So that's going to stay as S. Then we get the square root of 30. F is the friction, which it told us was 0.4. And then the distance is 110. In this case, they made the problem really easy for us. Because our variable's on this side, all I have to do is type that into the calculator to get our answer. And so we get the square root of 30 times 0.4 times 110. And that gives us 36.33. So she was going 36.33 miles per hour. All right. The next one here says the speed of sound near the Earth's surface can be found with the equation V equals 20 times the square root of T plus 273, where T is the surface temperature in degrees Celsius. Find the temperature if the speed of sound, V, is 356 meters per second. So in this case, we're going to put the 356 in for V. We need to solve for the T here. So in this case, we do have to solve for something that's inside that radical. So step 1 should be to get that part by itself. So we need to get rid of this 20. 20 and the radical are being multiplied, so I divide by 20. That's what's going to get that 20 to the other side and get my radical isolated. So 356 divided by 20 gives us 17.8. So we have 17.8 is equal to the square root of T plus 273. Now we're ready to square both sides since my radical is isolated. The square root and the square cancel. And we get 316.84 is equal to T plus 273. You never want to round until the very end of the equation. So if at all possible, you can round it as you write on the steps here, but make sure you're using the full answer as you solve. We subtract the 273, and we get T is equal to 43.84. So that is the degrees Celsius for what they describe as the speed of sound. All right, it says the speed of sound at Earth's surface is commonly given as 340 meters per second, but that would really only work for one temperature. So we're going to find that temperature. So 340 is equal to 20 times the radical plus 273. We divide by 20. We always want to get that radical by itself. It makes it a whole lot easier. And so we get 17 is equal to the square root of T plus 273. And we're going to go ahead and square both sides now. So square and square. Square root and square cancel. 17 squared is 289. That's freed. And so now we subtract our 273. And that is 16. So that's where they describe the speed of sound.